flywheels. I'll get into that a little bit. And it's got a lot of press recently. We've taken people from the state legislature, the California Energy Commission, Duncan Hunter was on. We'll get into that in a little bit. But
You're using a what?
pardon me?
The fractal grid?
It's a fractal grid, and what it is, 4 microgrids put together. I'll get into it a little bit more. We call it fractal grid, I'll get into that. It's very significant to what we're doing strategically for the future. MCAS Pendleton, again, it's part of the base up there. It's an air base on Pendleton also. They have a lot of solar PV. They want to light their entire airfield with LEDs. LEDs, by the way, we can talk about that all day. Is there any doubt about what kind of light they're going to do LEDs? I think that's going to, everything's going to be LEDs. Five years from now, everything will be LEDs. Everything in this room could be LEDs. You have to contact for SSC, which is a good idea, but LEDs are much better. Last longer, you can dim them, turn them on and off without affecting their life. But they're doing that with the airfields. MCAS Yuma, it's the only base not in California. Yuma, by the way, is the sunniest city in the United States. And so you might say, well, do all solar. They do. They put a lot of solar in there. But the problem is they're served by Arizona Public Service, which has very low rates. It's hard to show the economics of doing energy efficiency project there. But they do it. They do it very well. And they have another problem there. The Joint Strike Fighter was located there 2 years ago. They had to put in all new hangars there because basically these hangars are data centers. A data center, by the way, uses as much energy as like 5 houses. They use a tremendous amount of energy.
It's a good grief.
Yeah, they do. Because of all the electronics you have in there, run the electronics and all the heat given off the air conditioning. And so Yuma has a real challenge. I'll mention now, because I don't think I included in the microgrid discussion. Arizona Public Service approached us 2 years ago to put a microgrid on base, and we said, why, sure. And they're putting it in the right base. It makes a lot of sense. We have a microgrid there at APS. Let's see, MCRD San Diego, and again, this is one of the 2 bases here. They don't have microgrids yet, but we're hopeful for the future. Incidentally, these 2 bases are not part of NCI West. They're part of the Training and Education Command, but we support them as if they're one of our own with regard to infrastructure. And again, I talked about that a little bit earlier. We're trying to, I made a suggestion to headquarters one day to, let's put a microgrid there specifically for the intention of energy efficiency. You can do that. We'll talk about it a little bit. I haven't heard back what they want to do with it. Bridgeport. Bridgeport is way up north near Reno, and all soldiers and Marines that are going to Afghanistan trained at Bridgeport, because Bridgeport looks like Afghanistan, especially in the mountains. And 75% of their energy use, annual energy use, is propane because of the high heat load in the winter. So they could actually become a microgrid very easily because just truck in enough microgrids, store it, and that's all most of what they need. Okay, so that's an overview of what's going on in each basis, and I'm going to get into now my favorite topic. Any questions on renewable energy, what we're doing at the bases with regard to that? Okay, our strategy, we did our first strategy in August 2013. We finished it, and we did it with the assistance of Buell and Hamilton. My staff, I've got 4 staff members with Buell right now. They make up a regional energy and water advisory center, and they do energy for me, and it's worked very well. We did the strategy back in August of 2013. The main goal was to be energy and water security, primarily energy security, with a secondary goal of energy efficiency. I remember talking to Dave Heinrichs back at Marine Corps headquarters when we were doing this. They funded it, and by the way, we were the first region in the Marine Corps to do a strategy like this, and they were funding it for us. And I said, Dave, I'm going to make energy security our main goal. We want to do this with microgrids. Now, those of you who may be familiar with the politics in D.C., buzzwords run the gamut of being accepted or being not liked. And at the time, microgrids, nobody, if they mentioned it, they favorably. If they said, do you want to do that? I said, yeah, I'm going to do it because I think it makes sense. I'm glad he believed us. We instituted, it's been our goal for the last 3 years to put microgrids on these 4 bases, and I'll go into that in a moment. We haven't even planned or an operation on all our bases. And the microgrids were to provide a roadmap to energy security for all of our bases. And we're well on our way to doing that. Okay, that's the definition. Basically, that definition says, if you look at it, it's a Department of Energy definition, basically without reading it, anytime you have a subset of the grid which has its own loads, demands for electricity, plus its own distributed energy sources that can satisfy those loads, with the ability to operate either connected or disconnected from the grid. That is a microgrid. If you think about it for a second, hospitals have been microgrids for 100 years. They can operate off the grid because they have to. Automobiles come right down to are microgrids, but we're looking at microgrids right here to be able to operate our bases either connected or disconnected from the grid.
Oh,
Does anybody, I could get it, yes?
Have the military bases ever been dependent on utilities so that if some terrorist or some foreign enemy were to take down the utility grid, that the military bases would be in big trouble? Or
Yeah,
can
you'd be in trouble.
well, we're just civilians,
We'll be in
so.
trouble. No, that's why we're doing what we're doing, so we can get it right. Has anyone heard the book Lights Out? No. Ted Koppel just wrote a book. It was a bestseller on the LA Times bestseller list, and I'm finishing it right now. But he addressed this issue of somebody hacking the electrical grid in the United States. And I'm amazed. It's an interesting book, but not once does he mention microgrids in there as a solution. That would be a solution to that. If you were concerned about losing the grid in the United States, you develop microgrids in cities, and I'll get into that in a moment. I'm really surprised that he's not addressed it. Maybe part I haven't read yet. Address it.
when they go off grid, do they have a place to store it? Because you say you can disconnect from the grid. These microgrids can disconnect from the grid.
Yeah.
So do they have an off-grid storage for the,
Oh, it's, no, which line, created by connected load
or
distributed
an
energy.
Alamo? What is Alamo? Is that a storage, like a Tesla
Which
battery? What is it, how do they store the energy?
Oh, you, right up there, you generally have gas turbines, diesels, whatever, you have that. Or, the way it's better to do it is renewable energy. And that's what we're doing up in Pendleton. Our energy efficient, our energy storage is renewable energy, generally PV, and we also have storage. I'll get into it in a moment. Generally big batteries now, but there's a lot of ways you can do
Tesla
that.
has a $3,000. Tesla, I think, has a $3,000
Yeah,
battery.
yeah, I think they're doing the right thing. I mean, it's,
That's not,
yeah, Tesla, I'm not happy with Musk not looking.
well, it's not a car, it's a battery. That's what I like about it.
Oh, you're right, and I think he's gonna make it economic for everybody to have these things. But plus, a lot of people talking about microgrids, they talk about vehicle to business. In other words, you can power a building with a car battery. I mean, that's a lot of energy in these Teslas, 85 kilowatt hour in the bigger model. Now, a house, use, I think, 500 kilowatt hours, well, we won't done that, but it's a lot of opportunity right there using batteries, and that's part of it. Yes, sir.
I believe at one time that when the power went down in San Diego, that the University of California, San Diego, their microgrid actually powered the downtown in strategic
They put
areas.
some power on the grid. I don't know. There's some miscommunication. I know they did to a certain extent. You've heard from Byron Washington, a good friend of mine actually. He talks about that. Yeah, that go on to YouTube and Google microgrids, UCSD. You'll see a nice video. He put UCSD on the map worldwide because of that microgrid there. And they did. They put power on the grid. Use fuel cells, batteries. Anyway, so that's the definition right there. What it looks like is right there. Just pictorially, you see a well-defined area around an entity. An entity could be, in my case, in our case, military bases, but that could be a university, it could be a city. I was talking to Jay a little bit beforehand, maybe a microgrid providing something for Carlsbad, part of the city of Carlsbad. These are entirely valid things to be looking at. You can see there's an X out there. You lose the grid, and you can serve that load by, there's a backup diesel right there, there's some solar somewhere on there, and there's batteries, storage, anything will satisfy the loads. Okay? Okay, now our strategy, we completed the initial one in 2013. Primary goal was energy security. And why do we do this? There's so many reasons for this. Acts of God. We don't have hurricanes here and on the East Coast. We have earthquakes right here. An earthquake can take out electric grid very easily with never means. Excessive electrical demand. Come August or September in San Diego, SCGD's on the radio saying try to cut back unnecessary loads. That happens every year because we can just design the system to be so big. You just can't provide for that peak load easily in August and September. Cyber terrorism. Remember 3 years ago, Metcalf substation up in PG&E service territory, had 17 transformers shot up. Now, the FBI says it wasn't terrorism, but they're too quick to say that. I think a lot of people think it was. It was too well planned. Somebody could take out the entire electrical grid. But I don't think you have to go to all that effort to do it. You can take somebody out with a shotgun out to Imperial Valley where the 500 kV line coming into San Diego shoots that thing down. You're going to take out a huge amount of load. We're just fortunate it hasn't happened yet. There's a lot of easier ways to do that than to take out a substation like that. So cyber terrorism. But one way around that is, again, you guessed it, microgrids. Because you'd have to take out all these individual microgrids. Grid equipment failure. This was the blackout in Southern California was because somebody threw a wrench in a substation near Imperial Valley. And that's what took out the load for the entire Southern California for 12 hours. So there's a lot of ways to do it. Other benefits of microgrids. I was talking to Jay briefly coming in. People, especially when we're talking about microgrids starting 2 or 3 years ago, they talk about the expense of microgrids. They are expensive because you have to put a lot of stuff in there to make them work. But people don't talk about the energy efficiency. I was at a conference in August in Phoenix, and there was an individual. He was a he was a financial investor from Bostonia, and he was vice president of this Bostonia. He was up there giving a talk on microgrids. And I raised my hand after, and I said, "Oh, these folks invest in things to obviously make money. That's what you do these things for." And I says, "Can I ask you what the main source of energy savings is for your investments in microgrids?" And without blinking lighting, you can design that. You can design anything into it. You can make a microgrid do what you want to do right there. And it's funny, I ran into him 3 months later at a conference in Del Mar, and I recounted this story. I was on a panel. I recounted this story, telling everybody, and I didn't realize he was in the audience. And he came up to me afterward, chased me down, and said, "Hey, thank you." He was glad that I mentioned they're doing this. And I think it's the lesson here, a very important one, is if you are speccing a microgrid, you will do it in order to save money. That can be done. It can be done if you do it right. And where was I? Oh, no, I want to get back on this page here. Conservation voltage reduction, another way you can save energy with microgrids. Utilities have been doing CVR, conservation voltage reduction, for years. What they do is reduce the voltage at a substation. And anybody has any energy ideas or electrical engineers, when you reduce the voltage of something, it requires less energy. And so SCG used to do it, they may still be doing it, I don't know. The problem with doing that is if you do it to a customer at the end of a long feeder, you're already operating at low voltage. So if you reduce it, you begin to burn out motors and do a lot of things like that. So it's not done that often. But with a microgrid, by definition, you have shorter feeds, shorter distribution lines. So you can go ahead and do that all day. You're not going to lose load. So you may save money that way. Yes?
Yeah, isn't it the principle that the longer a distance you have to push electricity through the wires, you have to increase the voltage by decreasing the amperage. And then when you get to houses that have electrical equipment, you increase the amperage by decreasing the voltage.
Yeah, they're inverse proportion. That's why when you saw my first job at SCG&E, by the way, was building high voltage transmission lines, designing them. And that's why they're all high voltage, because 500 kV line uses a lot less amperage than a 230 kV line. That's just the rule of electrical engineering. Then when you get to the customer site, you take that voltage, you reduce the voltage, increase the current for the customer site. Yeah, that's been done since Tesla. Long time. Yes, that's what you do. Finally, demand response. Demand response, that's a program where you can sign up for SCG or SCE in August or September, take load offline and make money. What better way to do that than take your entire grid offline and save them money and get paid for it? So that's another benefit. Okay, let's see. We're getting toward the end for those of you who might. I went through most of this. I'm just going to say at each base, we either have a plant or an operation. That's Miramar. Anything new on that? No. That depends on the natural gas energy project. We are out to bid on that. We're evaluating bidders, and I guess by the summer we will have a contractor chosen. 200 Palms, we talked about that right there. Also, the thing I didn't mention, there are more solar PVs going in as part of the 1 gigawatt initiative by President Obama. Remember, State of the Union in 2012, he said each of the services will come up with 1 gigawatt of renewable energy. And we're there. We've done it. We've completed all the requirements for 1 gigawatt for Department of the Navy. We were involved in that at Pendleton also. Let's see. Pendleton, oh yeah, let me just say a few things about this. I glossed over before. Pendleton got $1.7 million about 4 or 5 years ago to develop a microgrid, and Harper Construction was doing a Mill Creek construction project, and what they did was not 5, it's 4 small microgrids up the northern part of the base. The key here is that if any one of these fails, it gets picked up by the others. So they're interconnected with these microgrids. This has very significant import for something I'll tell you in just a moment. By 533 kW of PV, one of which is concentrating solar. It's got an efficiency of about 30%, which you know is twice what it typically is there. So we got about 500 kilowatts there, because some other thing, plus flywheels. Flywheels is a big deal here, because anytime you have spinning mass, in this case it spins at about 5,000, 6,000 RPMs, you can have it run a generator. This thing can get 4 hours of storage. This particular flywheel there, if you have it spinning, it'll spin for 2 months if you don't take any energy out. 2 months, that thing will be spinning. There's an issue you might be familiar with this summer. They had Clean Spark in Poway. They had one of these flywheels that basically failed catastrophically. It wasn't the one we're using at Pendleton. We're looking beyond it. We're still working with them. More was made of it, although if you saw the site, it would look like a war zone. But anyway, that wasn't the one we're using. So,
So just bring us up to date on this, because we're all fascinated by the progress. So give us a little inside track on the flywheel, and are they producing? Are they working? Are you going to buy more of them? Are they cost effective?
Clean Spark signed a contract with South Africa to provide, what was it, 20,000 flywheels to build them over there. They're working with others, and it's very promising technology because they're non-toxic with regard to its compared to a battery. They're not toxic. You can start and stop these things without affecting their life, whereas with a battery you can. A battery will provide you about 60 megawatt hours of energy per acre, whereas flywheels will provide about 500 megawatt hours. And we'll stack them in the ground. And there's a lot of reasons. Now, all that said, Mike Ferenzi, the CEO of Clean Spark, we're good friends, and we talk about where they're working with batteries too, flow batteries. So the perfect technology has not been discovered yet. Flywheels, we're evaluating that with flow batteries and other means of storage where you can. The San Diego County Water Authority, they're planning. In fact, you heard what's his name?
Frank Beelock.
Frank Beelock. Jim Griffin's age, I was glad to hear that. 500 megawatt pump storage. Pump storage is by far the best way to go if you have a high elevation and a reservoir or lake at the top. And incidentally, one of my previous students, she's working for Frank now on that project. We had coffee the other day. Very promising, very promising. So energy storage is the key. It'll be key to community choice aggregation, anytime you're doing distributed energy, that's where you're going to get there. Yes?
So I'll kind of build on a couple of things in just a two-part thing. So let's go back and follow the money here a little bit. So we're talking with a DoD installation. You talked a lot about grants. Are we finding that this is now being appropriated as part of the DoD budget, or is it following how the Army is doing renewable installation with all third-party PPA type of things? And then how does the more risky innovation getting financed as well?
There's a couple ways to go. There are 2 third-party finance projects that you can do. And actually, you can do a PPA, power purchase agreement. You can do an energy savings performance contract. There are 16 contractors in the country can do that. It's very cumbersome, very involved to do that. Or you can do a utility energy savings contract. When I mentioned earlier for bar, so you can do that. The other ones have to be appropriate. An ESIP, Energy Conservation Improvement Program, they originate in Congress and have to be approved by Congress. We will not do any projects now unless they're bringing third-party finance, either PPA, UESC, or an ESPC, just because of the way money's funded. It's not there anymore. 3 or 4 years ago, a whole bunch of money. That's why I said the Marine Corps spent $500 million since 2009 on an energy project. It's not there anymore. Yeah. But rightfully so, we're finding ways to do this to get third-party financing.
And so on the innovation side, I noticed that you didn't mention hydrogen, and sort of hydrogen fuel cell, sort of as a storage alternative.
Yeah. I go on and on, that's one of my favorite subjects. We are proposing to the California Energy Commission now to develop a hydrogen production station right outside the gate on Marine Corps property. We work with the California Energy Commission. We have a 2-year time frame on it, because what we have to do is find a way to do sole source lease for the property and combine that with solicitation by the CEC. And most we can do is 18 months to 2 years. I want a fuel cell vehicle. I don't know if you know, but Hyundai is developing sites throughout California to work with the CEC to develop infrastructure. One is scheduled to go in at the corner of Carmel Valley Road and 5.
In Escondido.
No, in Carmel Valley. And if you get on the internet, put your zip code in, and I do it every once in a while, I want to get one. I think fuel cell vehicle is a better way to go. Because what you said, not only we're going to run the vehicle, you can run buildings with these things. I personally think we're going to be using fuel cells more in the future. And hydrogen is the most common element in the universe. Unfortunately, it's very expensive to produce. I mean, you can produce hydrogen. You can produce in your high school chemistry lab with fire, but it's very expensive to do. And that's the major problem. We don't have it. There's no hydrogen infrastructure in California. But the California Energy Commission is working to get there.
Well, it's good to hear that you're.
My money is on fuel cell EVs. Although, when you see the Tesla Model 3 next year, it's like a smaller version of the Tesla sedan by 2/3 the cost. Yeah, a lot of good things are happening. Okay, I'm near the end. If you're getting, okay, our goal now is to, sometime in the future, interconnect the 8 bases with their microgrids. And there's the 3 elements up there, diversity, the reason we can do this. And if you think about it for a second, those 8 bases could be 8 cities in California. I mean, look at Pendleton. Pendleton's big as a pretty good sized city. If you can bypass the utility and a major transmission right there, you can get additional benefits. Because what you're doing, some bases at given times, because of the wide diversity among our bases, some bases have excessive demand than others. They take generation and they can buy from the other bases and not go through the utility to do that. But in order to do that, you're going to have to work with the IOUs, investor-owned utilities, to reward them. I mean, it's their transmission lines. Going to use that, and it is 10 or 15 years ago. From now, you'll say, yeah, Bob said something like that is happening. It's going to happen. We're proposing to do this because of these advantages right there. MCI West coordinates infrastructure throughout the 8 bases. That includes energy projects. So the Commanding General of MCI West, also Pendleton, he can go ahead and say we're going to do that. We're headed in that direction right there because of all these things that are happening to make it work. And look at the last one there. We can put more renewable energy. Right now, there's a limit to the amount of renewable energy we can put on our bases because it's a limit to the amount they can use, the amount they can put onto the grid. But if you can do it such that Pendleton knows when they don't have a need for it, they can send it to Barstow. They can send it to Bridgeport. They can send it to Miramar. You can do this, by the way, not even with transmission, do it contractually. Make a deal with Edison and Bridgeport, and SCG&E and Pendleton, SCG&E and SC. You can do that. We can do that now if you want to. But right now, it's a very difficult political issue. Sorry.
Yeah, well, I was going to say, the way that you do that, if you're in a microgrid too, is that your PPAs are your own optics, and you can get around the rules that the utilities have for the length of those PPAs and what you're willing to pay for them if you're your own microgrid, right? So you're basically becoming a utility.
Yeah.
So you can have favorable contracts in terms of buying renewables, buying whatever you want to buy, and then wheel it around to your other bases.
Sure.
Right?
Yeah.
So that's the financing answer right there.
Yeah. It's not difficult. You just have to make it worthwhile for the utilities. They've got to, they got to get something out of it. Don?
Well, key question as far as making it worthwhile for the utilities. I think it's what 75% of our state's power is provided by 3 investor-owned utility monopolies.
Yeah.
And it seems to some of us that they are resistant to change. And
Believe me, they are.
by the time they come up
Anybody in here
with
associated with SCG&E? That's all right. I worked for 20 years. It's a good company. It's a good company. They do some dumb things once in a while, but they're shareholders, right? You've got to satisfy their shareholders.
And then to add another layer, the apparent corruption with the Public Utilities Commission that is supposed to be looking out for the ratepayers It seems to me it could be a real challenge to get something that really makes economic sense
Yep.
hammered out with the utilities and the Public Utilities Commission at this point in time.
Yeah, it was on the roundtable, that's what it was. Everybody in the NPR roundtable, they do it Friday and Sunday morning, and that was the topic right there. And PD, I think, I'll say that. Now, unfortunately, he was a Marine at one time, he was an electrical engineer, great career, I don't know why, whatever possessed him to meet for lunch with this idiot from PG&E in Krakow, Poland.
Could it have something to do with it? He used to be president for Southern California Edison?
Yeah.
Hiring the Fox to guard the hen house sort of thing never really made a whole lot of sense to me.
That doesn't necessarily disqualify him from that position. It was the guy before him did a pretty good job. He had been the president of SE too. Yeah. I mean, it can be done. It can be done. It wasn't done in this case. Questions? One more slide. Okay, I'm going to tell you why we ought to be doing this. Oh, that's a slide. I mentioned there because MCI West can make this thing work. We got a seat commanding general that can coordinate our 8 bases. And now here's something I want to leave you with right here. Remember this for the future. Given that existing power plants are only about 28 to 35% efficient. Does that shock anybody? I mean, that's how efficient they are. Power plants all across the United States. Transmission losses are generally 6 to 7% losses. That's just a fact. The result is about 30 to 40% efficiency of central station power plants. If for no other reason, everything I just told you, this means that we should not be generating 3 BTUs of energy to get 1 BTU to the customer. I'm amazed it's taken us this long to realize that. We have to do things like Lane's talking about. You go more to distributed generation, you go more to generation customer site. Anybody know Bill Powers? Bill Powers, anyway, he had an editorial on the page in the San Diego Tribune the other day. Caroline Wynn, who I used to work for, actually, she had a good, well-written article, she didn't write it, I'm sure. Bill Powers wrote another one. This is on NEM 2.0. What's going to happen this week, you're going to see sparks flying this week. But anyway, remember, it's taking us 3 BTUs under the current system to get 1 BTU for you, the customer, which is a dumb thing to do. And for that reason, if for no other, and hopefully I've given you a lot of other reasons in terms of energy security, to give you reasons to do this, we're going to do this. The efficiency of the proposed system is significantly improved by going to microgrids all over. One last thought. And this is something that only occurred to me recently. I feel like a lumber. I'm walking out and back. And one more thing. And I want to do this, get the numbers. I know they'll be impressive. If we take all the bases, now Pendleton pays about $24 million a year on energy bills. You can work that out, find out. Well, I know what their average load is. It's 26 megawatts. And so average 26 megawatts times 8760, give you the amount of megawatt hours being used. Did that for every base. And most of it they're buying from the utilities. And if you take, on average, 1 pound of CO2 per kilowatt hour, it's a good average for, San Diego might be a little bit less than that because we use a lot of natural gas. But you go to Ohio, it's about 2 pounds because of all the coal there. But if you figured this out and did the numbers for it, you're going to come up with a horrendous number of greenhouse gases saved by going to microgrids. You're not going to pay the utility to get this 3 BTUs to get you 1 BTU. And so the numbers there, I ought to do it just to come up with some impressive. They will be impressive. Yes, sir.
Is this because of the loss of power over long transmission?
That's part of it. That's only 6% of it. The other part is that the San Jose power plants up there at 28 to 35% efficient. Really inefficient. It's tackling on the large transmission losses. Yeah.
Plus, as far as the terrorism angle and everything, there's not a soldier with an M16 standing under every transmission of power. They march across the country for hundreds of miles, and like the people in San Bernardino that were not genius terrorists, they just walked into a government office and just started shooting people. It was a simple, and the same thing. The equivalent of them could just go to one of these towers, put a little dynamite over it, knock it down, and then an entire grid would go down.
That's why I tried that yet. Go out to Imperial Valley. You see the 500 kV line, Southwest Power Line. 500 kV line there. The Sunrise Power Line, another 500 kV line, and we've got several 230 kV lines coming down the coast. Any one of those, if you take it out there, what it's going to do is set in effect a bunch of power plants trimming off just because we're losing load, and the system will react by shutting everything down. That's fine, just surprised it's not happened yet. Oh, Don.
Back to one of your opening comments, about 10 years from now, someone else will be providing our energy. I understand with the Marine Corps, that's going to be the Marine Corps providing their energy. But back to cities, who do you see providing the energy? Right now it's generated by large corporations like NRG and using SDG&E's transmission lines to get the power to
I suspect it will still be the utilities, if they're smart, but they'll be doing 100 kilowatt fuel cells for communities. They'll be doing gas turbines, they'll be doing PV systems. And I know they want to keep their jobs, they want to keep their business, their industry. And like I said, the only way they're going to do that is by putting generation into rate base on the customer site. The way that APS is doing it at MCAS Yuma, and the way SG is ready to do it for a 15 megawatt PV site we have up at Pendleton. They were willing to finance that. We started talking until we changed a little bit the way we're going to do it. But they will do it. Utilities will. And I think it's smart. I think they can do it. They have enough smarts to do that, and it's regulated, or supposedly regulated. Yeah, I mean, well, you vote. We vote. When we complain about things, ask yourself, who did I vote for last time? If I don't like things, you get to change things. Okay, any other questions, comments? Good audience. Nobody's going to sleep. Thank you.
Did everybody enjoy that? I mean, was that an excellent overview? Although, I must say, I'm kind of concerned citizen, I'm not an expert like most of you people, but wow, it was a little bit in the weeds, but it was unbelievable. I mean, I learned more today in a lot of respects than I have in a long time because it put in factual ways how these things work together. So, Bob, I thank you so much for coming, and I thank everybody that got Bob to come here. I think we all learned a lot today. And the questions were very good, too. I mean, I was very impressed with the questions and interaction. Do you have anything else you wanted to say before?
No, I don't, but again, thanks for the invitation, I appreciate it being on. I'll hang around if you need to ask me anything, but otherwise I'm gonna pick off. My ride's probably gonna be open, but anyway.
Are you gonna be available outside, or do you wanna?
I'm gonna go outside, I'm gonna give Jenny a call, see if she'll pick me up.
Okay, before, a couple things we want to cover. We've got a few minutes to go, and I want to focus on a few local issues. First of all, everybody has an evaluation form. Would you please fill that out before you go today? We get information, and we get speakers based on the feedback you give us as well. So, first of all, we have Aaron. Aaron, would you like to briefly give we're going to talk about CCAPers. CCAPers are a group of people that are working on a climate action plan for Oceanside. We're going to be talking more about climate action plans. We heard about CCE today, Community Choice Energy and stuff. So would you start, and she has a flyer to turn out to you as well.
Okay, my name is Erin Warren, and I'm a farmer in Oceanside, California, and I'm very active with CAPers, which is Climate Action Planners for the city of Oceanside. We are a small group, and we meet every 2 weeks, Friday at South Coast High at the Hill Street Cafe. And what we decided, we came out with an outline of what we would like to see the city of Oceanside take action for.